This question is given in Anna University exam paper of May-June 2016, and the question is find the eigenvalues and eigenvectors of the matrix. Please refer my previous video Matrices Topics Introduction to know about this concept. And I will explain you how to do this now. So first thing is we have few steps to find out the eigenvectors. We need to find out first characteristic equation, and after that we need to find out eigenvalues, and after that eigenvectors. For each and every eigenvalue we'll get corresponding eigenvector. Characteristic equation is A minus lambda I is equals to 0. This simplified form of this characteristic equation for 3×3 matrix is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equals to 0, where S1 is equals to sum of the main diagonal elements, that is 1 plus 5 plus 1 is equals to 7, and S2 is the sum of the minors of the main diagonal element. Main diagonal element here is 1. The minor is determinant of this 5 1 1 1 1 plus next diagonal element is 5, and the minor of this element is determinant of 1 3 3 1. I already discussed these concepts in my previous videos. Plus last element is 1. The minor is determinant of 1 1 1 5 1 1 1 5. If you calculate these, you will get as 0. S2 is 0, and S3 determinant of A, that is 1 1 3 1 5 1 3 1 1. Determinant of A is minus 46. And if you substitute, you will get a characteristic equation, that is lambda cube minus 7 lambda square. Here S2 is 0, so this term will become 0, and minus S3, it is plus 46 is equals to 0. This is the characteristic equation, and the roots of this characteristic equation will be our eigenvalue. So first we need to solve this equation for the roots. I told you this method in previous video also, how to find out the eigenvalues. Just substitute 1 minus 1 like that and check whether you will get this term as 0 or not, whether this satisfies the equation or not. If you substitute 1 in this equation, you will get 1 minus 7 plus 46, which is not equal to 0, and if you put minus 1, you will get minus 1 minus 7 and plus 46, which is also not equal to 0. And let's try lambda is equals to 2. So alternatively we have to substitute 1 minus 1, 2 minus 2, like that. So if you put 2, then you will get 8 minus 28 plus 36, which is also not equal to 0, and again put minus 2. This will give you minus 8 minus 28 plus 36, so which is equal to 0. So lambda is equals to minus 2 is satisfying this equation. So this is one of the roots. Lambda 2 is one of the roots, and now we can write this characteristic equation as with the root minus 2, that is this characteristic equation is equals to lambda plus 2 into sum of the equation. To find out this equation, we need to use synthetic method, synthetic division method. Like below. So first we need to consider the coefficients of lambda, that is 1 minus 7, and lambda term here is 0. So we need to consider lambda term as 0 and constant plus 46, and take the root lambda is equals to minus 2. And first anyway we have to put 0 and add them up. 1 plus 0 is 1. And again multiply these two terms. Minus 2 into 1 is minus 2. And add these 2. Minus 9. And plus 18. So it gives you plus 18. And sorry, this one is 36. So this would be 36. So you will get minus 36 and you will get this term as 0. So this, using these coefficients, now we can write it as lambda square minus 9 lambda plus 18. Here we can substitute this. Root, rest of the equation will be lambda square minus lambda plus 18. Now, we have to solve this equation for another two roots. So, just use the calculator or also use this method. I am dividing this into lambda minus 6 into lambda minus 3 is equals to 0. And the roots are lambda is equals to 3, 6. So, now the total roots are here. Lambda is equals to minus 2, 3 and 6. So these are the eigenvalues of the given matrix. Now how to find out the eigenvectors? For each and every eigenvalue we will get one eigenvector. So here we will get 3 eigenvectors. Finding eigenvector. A minus lambda I into x is equals to 0, where x is the eigenvector, that is column of elements x1, x2, x3. So this formula is used to find out the eigenvector. And substitute A is the given matrix and lambda I is identity 3 by 3 matrix and x is the eigenvector x1, x2, x3. And here 0 is the 0 matrix. And simplify this matrix. So we'll get 1 minus lambda 1, 3, 1, 5 minus lambda 3 and 3, 1, 1 minus lambda. Into, as it is this one, we'll get column and 0 matrix. Now we have 3 lambda values and we need to put and simplify that to get eigenvectors. So this equation is the basic equation to find out the eigenvector. And case 1 I am considering as if lambda is equals to minus 2. Then the equation 1, this equation becomes, the substitute lambda is equals to minus 2. So you will get 1 minus of minus 2 is 3 here. 3 and other elements are as it is 1, 3, 1. Here we get 7, 1, 3, 1 and 3. X1, x2, x3. Now you multiply these two matrices and you will get 3x1 plus x2 plus 3x3. So this is 3 by 3 matrix and this is 3 by 3 matrix and this is 3 by 1 matrix. So you will get 3 by 1 matrix. That means 3 rows and 1 column. So you will get x1 plus 7x2 and just multiplying the above two matrices, 3x1 plus x2 plus x3, which is equals to 0 matrix. And now you can equate these equation to the elements 0 and you will get 3 equations. That is 3x1 plus 3x2 plus x2, 3x3 is equals to 0 and x1 3x1 plus x2 plus x3 is equals to 0. So these are the three equations we need to solve for x1, x2 and x3 values. These x1, x2 and x3 values will get by solving these three equations. Now use cross multiplication method to find out x1, x2 values, and here I am going to use 1 and 2 equations to find out those values. And first what we need to do is first leave the x1 coefficients and start with the x2 coefficients. So here write down like this: x1, x2, x3, and x2 coefficients are 1 and 7. So start with that 1 and 7, and x3 coefficients are 3 and 1. So 3 and 1, and again x1 coefficients are 3 and 1, 3 and 1, and x2 coefficients are again 1 and 7. So here first whatever we will start with one coefficient, and we should end with the same coefficients. And now write down using cross multiplication, that is x1 value is x1 by 1 into 1. We need to multiply 1 and we'll get 1 minus 7 3 is 21 and 3 1 is 3 and 1 minus 1 3 is 3, and x3 3 7 is 21 minus 1 1 is 1. These are the values after solving the denominator. We can directly take these values are x1, x2, x3. That is, eigenvector x1 is minus 20, 0 and 20. From here, the denominators are the values. And if you solve with, if lambda is equals to 3, then we'll get this x2 value as minus 5, 5, minus 5. So you use the same method and put lambda is equals to 3 value in this first equation, and you will get the x2 vector. And if lambda is equals to 6, then put the 6 value in this first equation and solve using the same method. So you will get x3 as 4, 18, 4. So these are the values x1, x2, x3. These are the required eigenvectors.